And now in this lecture we'll answer two questions. In the first question, we'll find out the radius of this circle. And in the second question, we'll find out the area of this semicircle APQB. So we'll start with the first question. In the domain, we have a circle. This is line segment CP. This is equal to 12 units in its length. This is line segment AP. This is equal to 3 units in its length. This is line segment PB. That is equal to 4 units in its length. This is angle CPB. That is equal to 60 degrees in its size. And our task is to find out the radius of this circle. So first of all, it is given us the question that AB is a straight line. So if you focus on the upper side of the straight line AB at point P, here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the areas on one side of the straight line is equal to 180 degrees. So which areas we have at the upper side of the straight line AB at point P? We have this angle is equal to 60 degrees in size, plus this missing angle. In total, the sum of those two areas must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 120 degrees in its size. In the next step, we'll join points C and B together by straight line. And we join points C and A together by straight line. By doing those constructions, we can do three triangles. This is the first green triangle APC. And we also have the white triangle CPB. And the third triangle is triangle ABC that consists of those two smaller triangles. So in the next step, we will implement the law of cosines on all those three triangles. So we'll start with the green triangle ACP. So I print quickly on the law of cosines. The law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. Side AB equals to A units in its length, side BC equals to C units in its length, side AC equals to B units in its length. This is angle BAC. This equals to theta degrees in its size according to our definition. So this triangle ABC that could be any triangle according to the law of cosines. The following equation is true. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So we'll implement the law of cosines on this green triangle, triangle CAP. On the green triangle CAP, according to the law of cosines, the following equation is true. CA squared so theta is the angle and this angle is equal to 120 degrees in its size. So according to the law of cosines, in this green triangle CAP, CA squared equals to AP squared plus CP squared minus 2 times AP times PC times cosine 120 degrees. Repeat again, in this green triangle CAP, according to the law of cosines, the following equation is true. CA squared equals to AP square plus CP square minus 2 times AP times CP times cosine 120 degrees. CA is the missing side, so we leave it as it is, so it is CA square equals to AP squared. AP is 3, therefore AP squared is 3 squared, that is 9, plus PC squared. PC is 12, therefore PC squared is 12 squared, that is 144. Minus 2 times AP is 3, times CP is 12, times cosine 120 degrees, cosine 120 degrees equals to minus 1/2. So in total, we found out that CA square equals to 9 plus 144 is 153, plus we have minus times minus is plus, so this expression is a positive expression. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. We left only with, once I cancel 2, we left only with 3 times 12, that is 36. So in total, this expression equals to 36. So this plus 36, and CA square equals to 153 plus 36. 153 plus 36 is 189. So CA square equals to 189. Here we take out of this equation and finally get that CA equals to the square root of 189 units in its length. This is side CA. This equals to the square root of 189 units in its length. So write it down. CA equals to the square root of 189 units in its length. And CA square equals to 189. Likewise, we implement the law of cosines on this right triangle, triangle CPB. On this right triangle CPB, according to the law of cosines, the following equation is true. We choose angle theta as this angle, that is angle CPB, that equals to 60 degrees in size. So according to the law of cosines, in this triangle CPB, the following equation is true. CB square equals to PB square plus PC square minus 2 times PB times PC times cosine 60 degrees. Repeat again, this right triangle CPB, according to the law of cosines, the following equation is true. CB square equals to PB square plus PC square minus 2 times PB times PC times cosine 60 degrees. CB is the missing side, so we leave it as it is. It is CB square equals to PB square. PB is 4, therefore PB square is 4 squared, that is 16, plus PC square. PC is 12, Therefore PC squared is 12 squared, that is 144. Minus 2 times PB is 4 times PC is 12 times cosine 60 degrees. Cosine 60 degrees equals to 1/2. So in total, we found out that CB squared equals to 16 plus 144 is 160. So here we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. After we cancel 2, we left only with minus 4 times 12 is minus 48. So in total this expression equals to minus 48. And CB squared equals to 160 minus 48, that is 112. So CB squared equals to 112. Here we take out of this equation and finally get that CB equals to the square root of 112 units in its length. This is the missing side CB, that is equals to 112 units, the square root of 112 units in its length. So it is known CB equals to the square root of 112 units in its length. And CB squared equals to 112. In the next step, we define this angle, this is actually angle BAC, as alpha. And we will implement the law of cosines on this big triangle, triangle ABC. It shows angle theta as alpha. So, in this big triangle ABC, according to the law of cosines, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. Repeat again, according to the law of cosines, in this big triangle ABC, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times minus 2 times CA times AB. Times cosine alpha. Repeat again, according to the law of cosines, in this big triangle ABC, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. We have already found out that CB squared equals to 112 and it equals to CA squared. CA squared equals to 189 plus AB squared. AB in total equals to AP plus PB. AP is 3, PB is 4, so in total AB equals to 3 plus 4, that is 7. AB equals to 7, therefore AB squared equals to 7 squared, that is 49. Minus 2 times CA. CA equals to the square root of 189 units in itself, so it is minus 2 times square root of 189 times AB. AB equals to 7. Cosine times cosine alpha. So in total, if you found out that 112 equals to 189 plus 49 is 238. Here we have minus 2 times 7 is minus 14, so in total this expression equals to minus 14 times square root of 189 times cosine alpha. So in total, if you found out that 112 equals to 238 minus 14 times square root of 189 times cosine alpha. Here we will subtract from this equation 112. So in this side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have 238 minus 112 is 126. And here we have minus 14 times the square root of 189 times cosine alpha. Here we add to this equation minus 14 times square root of 189 times cosine alpha. That is to say, we will move this expression to the other side of the equation. So in total we find out that 14 times the square root of 189 times cosine alpha equals to 126. So here we'll divide this equation by 14. So in this side of the equation 14 over 14 is 1, so left only with square root of 189 times cosine alpha. Equals to 126. Here we divide this equation by square root of 189. You get that cosine alpha actually in this side of the equation we have square root of 189 times cosine alpha, while on the other side of the equation we have 126. 126 over 14 is 9. So in this side of the equation we have only 9. We left only with 9. So I'll take down again. In total we should find out that the square root of 189 times cosine alpha equals to 14. So here we'll divide this equation by square root of 189. You get that cosine alpha equals to 14 over square root of 189. Here we substitute 189 by 9 times 21, and you get that cosine alpha equals to 14 over square root of 189 is 9 times 21. In the next step we'll take out 9. We take 9 out of the root. The square root of 9 is 3, so inside the root we left only with 21. So in total we found out that cosine alpha equals to made a mistake here. Cosine alpha equals to, it's actually 126 over 14 is 9. And then again 126 over 14 is 9. So it is not 14 but 9. So here's for 9. Here's also 9. So in total, if you found out that cosine alpha equals to 9 over 3 times square root of 21. Write that down again. In total, if you found out that cosine alpha equals to 9 over 3 times square root of 21. Here we divide both the numerator and the denominator of this expression by 3 and get that cosine alpha equals to 9 over 3 is 3, 3 over 3 is 1, so we left in the denominator, we left only with square root of 21. In total, we should find out that cosine alpha equals to 3 over square root of 21. In the next step, we present you a new trigonometric identity, and we will implement the new trigonometric identity. We find out that the value of cosine alpha, and then we find out the value of cosine square alpha, and we use the new trigonometric identity in order to find out the value of sinus alpha. The trigonometric identity here, TA is a version for trigonometric identity. The trigonometric identity is as follows: sinus square alpha plus cosine square alpha equals to 1. Here we subtract from this trigonometric identity cosine square alpha, and get that sinus square alpha equals to 1 minus cosine square alpha. So here we take a root out of this equation and finally get that sinus alpha equals to the square root of 1 minus cosine square alpha. We already found out that cosine alpha equals to 3 over square root of 21. So here we'll square this equation, and we get that in this side of the equation we have cosine square alpha, and on the other side of the equation we have to square this expression. It will be 3 squared, that is 9, over square root of 21 squared, that is 21. So in total, if you found out that cosine alpha equals to 9 over 21. Cosine square alpha equals to 9 over 21. So in the next step, we substitute cosine square alpha in this trigonometric identity by 9 over 21. And you get the sinus alpha equals to the square root of 1 and cosine square alpha minus cosine square alpha. Cosine square alpha is 9 over 21. So in total, if you found out that sinus alpha equals to the square root of 1 minus 9 over 21. So it is equals to 1 minus 9 over 21. Here we multiply 1 by 21 and then we will divide it by 21 in order to have a common factor with this number. So it is 21 times 1 is 21 minus 9 over 21. We multiply 1 by 21 and then we divide it by 21, so we change nothing. It is allowable to multiply anything by 1. So we have here 21 minus 9 is 12 over 21. Here we divide both the numerator and the denominator of this number by 3. And we get that 12 over 3 is 4 and 21 over 3 is 7. So in total, we found out that sinus alpha equals to the square root of 4 over 7. Here we take 4 out of the root. The square root of 4 is 2. So inside the root we left only with 7. So in total, we actually found out that sinus alpha equals to 2 over square root of 7 units, or square root of 7. Sinus alpha equals to 2 over square root of 7. Repeat again. If you found out that sinus alpha equals to 2 over square root of 7. In the next step, we will implement the law of sines on this big triangle, triangle ABC. So repeat quickly on the law of sines. The law of sines is true in any triangle. So this is triangle ABC that could be any triangle. This triangle ABC, side AB equals to 3 units in its length, side AC equals to B units in its length, side BC equals to A units in its length. Triangle ABC is described by this circle. The radius of this circle is R. So according to the law of sines, this triangle ABC, the following equation is true. A over here, capital A is the size of angle BAC, while capital B is the size of angle ABC, and capital C is the size of this angle, angle ACB. So according to the law of sines, in this angle ABC, that is described by this circle, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. Repeat again, according to the law of sines, in this triangle ABC, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we can implement the law of sines on this big triangle, triangle ABC. According to the law of sines, on this big triangle, triangle ABC, the following equation is true. But before that, it is very clear that triangle ABC is described by this circle. Why triangle ABC is described by this circle? Because of the fact that all the 3 vertices of triangle ABC lie on the circle itself. So triangle ABC is described by this circle. Therefore, we can implement here the full version of the law of sines. So according to the law of sines, in this triangle ABC, the following equation is true. CB over sinus alpha equals to 2R. Again, CB over sinus alpha equals to 2R, and R is the radius of this circle that blocks triangle ABC. Write it down. The triangle ABC, according to the law of sines, the following equation is true. CB over sinus alpha equals to 2R. R is the radius that we are looking for in this question. R is the radius of this circle. We already found out that CB equals to 112. CB equals to the square root of 112 units in its length. Here CB equals to the square root of 112 units in its length. And we just right now found out that sinus alpha equals to 2 over square root of 7. So, according to this equation, CB is square root of 112 over sinus alpha is 2 over square root of 7 equals to 2R. So we found out that the square root of 112 over 2 over square root of 7 equals to 2R. We'll substitute square root of 112 by 16 times 7, and we get that the square root of 112 is 16 times 7 over 1 over 2 over square root of 7 equals to 2R. Here we take 16 out of the root. The square root of 16 is 4, so inside the root we left only with 7. So it is this expression in total equals to 4 times square root of 7 over 1 over 2 over square root of 7. equals to 2r. So here we remove square root of 7 to the numerator and 2 to the denominator, and we find out actually that, so here we have square root of 7, 4 times square root of 7 times square root of 7 in the numerator over 2 equals to 2r. Here 4 over 2 is 2, so in total this expression equals to 2 times square root of 7 times square root of 7 equals to 2r. Here we have 2 on both sides of this equation, so 2 will get cancelled, and we have only with square root of 7 times square root of 7, that is 7, equals 2r. So in total, we actually found out that the radius that we are looking for in this equation, that is the radius of this circle, is equal to 7 units in its length. So we finish with the first question. In the next step, we'll present you the second question, and we'll answer the second question of this lecture. In the second question, our task is to find out the area of this semicircle APQB. In the drawing, we have semicircle. This is line segment PC. That is equal to 21 units in its length. This is line segment PQ. That is equal to 16 units in its length. This is angle CPQ. That is a right angle. Again, our task is to find out the area of this semicircle APQB. So first of all, we will define the radius of this semicircle as x. So if the radius is x, then the diameter AB is 2x. The diameter AB equals to 2x. And therefore, this is the missing line segment CB. CB in total equals to AB minus AC. Again, CB equals to AB minus AC. So the norm CB equals to AB minus AC. So CB in total equals to AB. AB is 2x. This is the diameter of the circle, of the semicircle, minus AC. AC equals to 7 units in itself according to what is given as the question. So in total, we actually found out that CB equals to 2x minus 7 units in its length. This is the missing line segment CB. That is equals to 2x minus 7 units in its length. In the next step, we will complete this semicircle to a circle. So I completed the semicircle to a circle, and we'll extend line segment BC by side line until it touches the circle. And we will define the touching point of the extended line segment PC with this circle. This point is point M. Likewise, we'll define the short line segment MC as A. So in the next step, we will implement Rule 65 in our drawing. Rule 65 is about two chords that intersects with each other inside the circle. So I repeat quickly on rule 65. According to rule 65, first of all, rule 65 is true in any circle. So this circle could be any circle. According to rule 65, if chord AB intersects with chord CD at point O, then the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can implement rule 65 in our drawing. Why? Because in our drawing, we have chord AB that intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. So, write it down. Chord AB intersects with chord PM at point C. The intersection point of chord AB with chord PM occurs at point C. So all the requirements of rule 65 are satisfied, and therefore we can implement rule 65. According to rule 65, the following equation is true. AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. So this equation is the implementation of rule 65 in our drawing. AC is 7 times CB. CB is 2x minus 7, and it is equals to PC. PC is 21 times CM. CM is A. So in total, we found out that seven times 2x minus 7 equals to 21a. Here we will divide this equation by 7, and we get that here 7 will get cancelled, and we left only with 2x minus 7 equals to 21 over 7 is 3, so in total this expression equals to 3a. So in total we found out that 2x minus 7 equals to 3a. Here we relate to this equation 7 and get that 2x equals to 3a plus 7. 2x equals to 3a plus 7. In the next step, we'll join points Q and M together by a straight line. By joining points Q and M, we created the right triangle QPM. Repeat again. By joining points Q and M, we created the right triangle PQM. This is peritriangle MPQ. Peritriangle MPQ equals to 90 degrees in size, and peritriangle MPQ subset on this chord called QM. Therefore, we can implement here rule 5. So repeat quickly on rule 5. According to rule 5, any peritriangle that is equal to 90 degrees in size must subtend on the diameter of the circle. In the drawing, we have a circle. This is peritriangle MAN, that is equal to 90 degrees in size, and peripheral angle MAN subtend on chord MN. And because of the fact that peripheral angle MAN is a right angle, it must subtend on the diameter of the circle. And indeed, peripheral angle MAN subtend on chord MN, that is the diameter of this circle. So according to this rule 5, any peripheral angle that is equal to 90 degrees in size must subtend on the diameter of the circle. We can implement rule 5 in our drawing. Why? Because in our drawing, this is a peripheral angle MPQ that is equal to 90 degrees in size, and therefore it must subtend on the diameter of the circle. Peripheral angle MPQ subtend on chord QM, and therefore chord QM must be the diameter of this circle according to rule 5. The radius of this circle is x, therefore the diameter is 2x. Diameter MQ equals to 2x, unity in time. In the next step, we will implement the Pythagoras theorem on this right triangle MPQ. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle MPQ, right triangle MPQ, here by PT is the version for Pythagoras theorem. So in this right triangle MPQ, according to the Pythagoras theorem, the following equation is true. QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. And again, according to the Pythagoras theorem, on this green right triangle PQM, the following equation is true. QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. The hypotenuse QM equals to 2x, therefore QM squared is 2x squared. And it is equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 256. Plus PM squared. PM total is PC, that is 21, plus CM, that is 8. So total PM equals to 21 plus 8, therefore PM squared equals to 21 plus 8 squared. So in total, we found out that 2x squared equals to 256 plus 21 plus 8 squared. We have already found out that 2x equals to 3a plus 7. So we substitute 2x in this equation by 3a plus 7. If 2x equals to 3a plus 7, it means that 2x squared equals to 3a plus 7 squared. And it is equal, on the other side of the equation, we have 256 plus 21 plus 8 squared. Here we'll open the brackets on both sides of this equation, and we get that 3a plus 7 squared equals to 3a squared. 3a squared is 9a squared plus 7 squared. 7 squared is 49, plus 2 times 3a times 7 is 42a. Equals to 256 plus 21 plus a squared. 21 plus a squared equals to 21 squared, that is 441. 21 squared is 441 plus a squared plus 2 times 21 times a is 42a. So here we have 42a on both sides of this equation, so 42a will get cancelled. After we cancel 42a, this side of the equation we have we're left with 9a squared plus 49 equals, on the other side of the equation, 256 plus 441 equals to 697 plus a squared. So in total, we found out that 9a squared plus 49 equals to 697 plus a squared. Here we subtract a squared from this equation, and we get that 9a squared minus a squared is 8a squared plus 49 equals to 697. Here we subtract 49 from this equation, and we get that in this side of the equation we left only with 8a squared. A squared equals to 697 minus 49 is 648. So in total we found out that 8a squared equals to 648. Here we will divide this equation by 8, and finally we get that 8a squared over 8 is a squared equals to 648 over 8 is 81. So in total actually found out that a squared equals to 81. Here we'll take a root out of this equation and finally get that a equals to the square root of 81, that is 9. A equals to 9 units in itself. This is 9 cm. This equals to a, and it is equals to 9 units. So our task is to find out the area of this semicircle. We already found out that 2x equals to 3a plus 7, so I'll copy this equation here. X equals to 3a plus 7. So 2x equals to 3a. A is 9, therefore 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 34. So in total we found out that 2x equals to 34. Here we divide this equation by 2 and find again that x equals to 34 over 2 is 17. X equals to 17 units in its length. That is to say, we have found out that the radius of this semicircle, x equals to 17 units in its length. Again, our task is to find out the area of this semicircle, semicircle APQB. Actually, we know that the area of any semicircle is equal to pi times the radius of the semicircle squared over 2. Therefore, the area of this semicircle must be equal to pi over 2 times the radius of this semicircle, that is x squared. So it is pi over 2 times x squared. So in total we found out that the area of our semicircle equals to pi x squared over 2. But we just now found out that x equals to 17, therefore x squared is 17 squared. So in total the area of our semicircle equals to pi over 2 times 17 squared. Actually, pi over 2 times 17 squared equals to pi over 2 times 289. So in total we found out that the area of this semicircle equals to either 289 pi over 2 square units in size, or in terms of numbers, the area of this semicircle equals to 453.96 square units in its size. And again, we found out that the area of this semicircle, that is the area that we are looking for in this question, it is equal to either 289 pi over 2 square units in size, or in terms of numbers, the area of this semicircle equals to 453.96 square units in its size. So we finish with the second question. In the next step, I will sum up the lecture. That is to say, we will repeat on the solution of the first question, and then we will repeat on the solution of this second question. the first question, our task was to find out the radius of this circle. So in the drawing, we have a circle. This is line segment CP, that is equal to 12 units in its length. This is line segment PB, that is equal to 4 units in its length. This is line segment AP, that is equal to 3 units in its length. This is again CPB, that is equal to 60 degrees in its size. Again, our task was to find out the radius of this circle. It is given as a question that AB is a straight line. So if we focus on the upper side of the straight line AB at point B, here the sum of the angles must be equal to 180 degrees according to Rule 3. Rule 3 said that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point B? We have this angle that is equal to 60 degrees in size, plus this missing angle. Total the sum of those angles must be equal to 180 degrees according to Rule 3. Therefore this missing angle must be equal to 120 degrees in size. And again, this missing angle must be equal to 120 degrees in size according to Rule 3. In the next step, we join point C and B together by a straight line, and join point C and A together by a straight line. By doing these constructions, we get here 3 triangles. The green triangle, the white triangle, and the big triangle ABC that consists of those 2 smaller triangles. So in the next step, we implemented the law of cosines on all those 3 triangles. So first of all, we implemented the law of cosines on this green triangle ACP. So repeat quickly on the law of cosines. First of all, the law of cosines is true in any triangle. This is triangle ABC that could be any triangle. The length of side AB is A units, side BC equals to C units in its length, side AC equals to B units in its length. This angle BAC is equals to 30 degrees in size according to our definition. So in this triangle ABC that could be any triangle according to the law of cosines, the following equation is true. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So we're going to implement the law of cosines on this green triangle, triangle CAP. According to the law of cosines, this green triangle CAP, we choose angle theta, this angle APC, is equal to 120 degrees in size. So according to the law of cosines, this green triangle CAP, the following equation is true. CA squared equals to AP squared plus PC squared minus 2 times AP times PC times cosine 120 degrees. And again, this green triangle CAP according to the law of cosines, the following equation is true. CA squared equals to AP squared plus CP squared minus 2 times AP times CP times cosine 120 degrees. So CA is the missing side, so we leave this as it is. So it is CA squared equals to AP squared. AP is 3, therefore AP squared is 3 squared, that is 9. Plus PC squared. PC is 12, therefore PC squared is 12 squared, that is 144. So in total we have CA squared equals to 9 plus 144 minus 2 times AP, that is 3, times CP, that is 12, times cosine 120 degrees. Cosine 120 degrees equals to minus 1/2. So in total we should find out that CA squared equals to 9 plus 144, that is 153. And here we have minus times minus is plus, so this expression in total it is a positive expression. We have 2 in the numerator, 2 in the denominator, so 2 get cancelled. So this expression in total equals to 3 times 12, that is plus 36. So in total we found out that CA squared equals to 153 plus 36, that is 189. CA squared equals to 189. Here we took out of this equation and finally found out that CA, the missing side CA, equals to the square root of 189 units in its length. This is the missing side CA, this is equal to the square root of 189 in its length, and CA squared equals to 189. Likewise, we implemented the law of cosines on this right triangle, triangle CPB. We chose angle theta, and this angle CPB is equal to 60 degrees in its size. So according to the law of cosines, in this right triangle CPB, the following equation is true. CB squared equals to CP squared plus PB squared minus 2 times CP times PB times cosine 60 degrees. But again, according to the law of cosines, in this right triangle CPB, the following equation is true. CB squared equals to PB squared plus PC squared minus 2 times PB times PC times cosine 60 degrees. So CB is the missing side, so we leave this it is. And it is equals to PB squared. PB is 4, therefore PB squared is 4 squared, that is 16, plus PC squared. PC is 12, therefore PC squared is 12 squared, that is 144. Minus 2 times PB is 4, times PC is 12, times cosine 60 degrees. Cosine 60 degrees is 1 half. So in total, we actually found out that CB squared equals to 16 plus 144, minus 2 times 4 times 12 times 1 half. 16 plus 144 is 160. Here we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled, and we left only with minus 4 times 12, that is minus 48. So in total, we found out that CB squared equals to 160 minus 48, that is 112. CB squared equals to 112. Here we took out all of this equation, and I found out that the missing side CB is equal to the square root of 112 units in its length. This is the missing side CB. This is equal to 112 units in its length, and of course CB squared equals to 112. In the next step, we define this angle BAC is alpha, and implemented the law of cosines of this big triangle ABC. So we choose angle theta is alpha, and according to the law of cosines in this triangle ABC, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times CB times cosine alpha. But again, in this triangle CAB, according to the law of cosines, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. We already found out that CB squared equals to 112, and it is equals to CA squared. CA squared is 189 plus AB squared. AB is 3 plus 4, that is 7, therefore AB squared is 7 squared, that is 49, minus 2 times CA is square root of 189, times AB is 7. So in total, we found out that 112 equals to 189 plus 49, minus 2 times square root of 189 times 7 times cosine alpha. So here we have 112 equals to 189 plus 49, that is 238. Here we have minus 2 times 3 is minus 14, minus 2 times 7 is minus 14. So this expression in total equals to minus 14 times square root of 189 times cosine alpha. So here we subtracted 112 from this equation, and finally found out that this side of the equation we left with nothing, that is to say 0, while on the other side of the equation we have 238 minus 238 minus 112 is 126, equals to minus 14 times square root of 189 times cosine alpha. So here we added we added 14 times square root of 189 times cosine alpha to this equation. That is to say, we move this expression to the other side of the equation. And finally found out that 14 times square root of 189 times cosine alpha equals to 126. Here we divided this equation by 14, so here 14 over 14 is 1, so we left only with square root of 189 times cosine alpha. Well, on the other side of the equation, we have 126 over 14 is 9. So in total, we found out that square root of 189 times cosine alpha equals to 9. Here we divided this equation by square root of 189, and finally found out that cosine alpha equals to 9 over square root of 189. So we substituted 189 by 12 times 9. We substituted 189 by 9 times 21. And the total we found out that cosine alpha equals to 9, and 189 is 9 times 21. Here we took 9 out of the root, so the square root of 9 is 3, so inside the root we left only with 21. So in total we actually found out that cosine alpha equals to 9 times 3 over square root of 21. So here we divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3 and 3 over 3 is 1, so in total this expression equals to 3 over square root of 21. So if you found out that cosine alpha equals to 9 over 3 times square root of 21, so repeat again, we divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3 and 3 over 3 is 1, so the denominator left only with square root of 21. So in total, we actually found out that cosine alpha equals to 3 over square root of 21. The next step, we implemented the trigonometric identity that said that sin square alpha plus cosine square alpha equals to 1 in order to find out the value of sinus alpha. So here we subtracted cosine square alpha from this trigonometric identity and found out actually that sin square alpha equals to 1 minus cosine square alpha. In the next step, we took a root out of this equation and found out that sin alpha equals to the square root of 1 minus cosine square alpha. Again, sin alpha equals to the square root of 1 minus cosine square alpha. We already found out that cosine alpha equals to 3 over square root of 21. So we squared this equation and we have cosine square alpha, We squared also this equation, both sides of the equation, so we squared also the other side of the equation. 3 over square root of 21 is 3 squared, that is 9, times square root of 21 squared is 21. So in total we found out that cosine square alpha equals to 9 over 21. Now we can substitute cosine square alpha in this equation by 9 over 21. We did it and actually found out that sinus alpha equals to the square root of 1 and cosine square alpha is 9 over 21. So, and it's equals to, here we multiplied 1 by 21 and then we divided by 21 in order to overcome a factor with this number. So 21 times 1 is 21 minus 9 over 21. We multiplied 1 by 21 and then we divided by 21, so we change nothing. It is allowable to multiply anything by 1. So in total, we found out that sinus alpha equals to 21 minus 9 over 21. 21 minus 9 is 12. So in total, this expression equals to the square root of 12 over 21. Here we divided both the numerator and the denominator of this number by 3. 12 over 3 is 4 and 21 over 3 is 7. So in total, we found out that sinus alpha equals to the square root of 4 over 7. Here we took 4 out of the root. The square root of 4 is 2. So inside the root we left only with 7. So in total, we actually found out that sinus alpha equals to 2 over square root of 7. Again, sinus alpha equals to 2 over square root of 7. Sinus alpha equals to 2 over square root of 7. In the next step, we implemented the law of sines on this big triangle ABC. This is angle alpha. Angle CAB equals to alpha according to our definition. So quickly on the law of sines. The law of sines is true in any triangle. This is a triangle ABC that could be any triangle. Side AB of triangle ABC equals to 0 incidence length, side BC equals to N incidence length, side AC equals to B incidence length. This is angle BAC, that is equals to capital A degrees according to our definition. Likewise, this is angle ACB, this is equal to capital C degrees, and this is angle ABC, this is equal to capital B degrees in its size. Triangle ABC is described by this circle. The radius of this circle is R. So in this triangle ABC, that could be any triangle, the following equation is 2. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. So we can implement the law of sines in its full version in this triangle ABC. First of all, triangle ABC is described by this circle. Why triangle ABC is described by this circle? Because of the fact that all the 3 vertices of triangle ABC lie on the circle. Therefore, we can implement the law of sines in its full version. So this triangle ABC, according to the law of sines, CB over sinus alpha equals to 2R. Okay, the full version is that A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And we have another version that is not a full version, that A over sinus A equals to B over sinus B equals to C over sinus C. That is to say, it is true for any triangle that is not necessarily inscribed by a circle. In any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. Our triangle ABC is described by this circle. ABC is described by this circle, and therefore we can implement the law of sines in its full version. That is to say, A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So according to the law of sines, this triangle ABC, we get that CB over sinus alpha equals to 2R. And R is the radius of this circle that blocks triangle ABC. R is the radius that we are looking for in this question. So total, according to the law of sines, we found out actually that in triangle ABC, CB over sinus alpha equals to 2R. We only found out that CB equals to the square root of 112 units in itself, and sinus alpha equals to 2 over square root of 7. So in total, CB is square root of 112 over sinus alpha is 2 over square root of 7 equals to 2R. Here we substitute CB, we substitute 112 by 16 times 7, so the square root of 112 is the square root of 16 times 7 over 2 over square root of 7. We took 16 out of the root, the square root of 16 is 4, so inside the root we left only with 7. So in total this expression equals to 4 times square root of 7 over 2 over square root of 7. So here we moved square root of 7 to the numerator and 2 to the denominator. And in total we found out that 4 times square root of 7 times square root of 7 over 2 equals to 2R. 4 over 2 is 2, so in total this expression equals to 2 times square root of 7 times square root of 7 equals to 2R. We have 2 on both sides of this equation, so 2 will get cancelled, and we left only with square root of 7 times square root of 7, that is 7, equals to R. So in total we found out that the radius of this circle is equal to 7 units in its length. So we finish to repeat on the first solution. In the next step, we repeat on the solution of the second question. The second question, our test is to find out the area of this semicircle, APQB. So in the drawing we have a semicircle. This is 97PC, this is equals to 21 units in its length. This is 97PQ, this is equals to 16 units in its length. This is angle CPQ, this is a right angle. This is 97AC, this is equals to 7 units in its length. Again, our test is to find out the area of this semicircle APQB. So first of all, we define the radius of this semicircle as x. Okay, so the radius of this semicircle equals to x according to our definition. It is given as an equation that AB is a straight line. So again, first of all, define the radius of this semicircle as x. If the radius is x, then the diameter AB is 2x. So what is the length of this line segment CB? From the drawing it is very easy to see that CB in total equals to AB minus AC. CB equals to AB, AB is 2x, it is the diameter of this semicircle, minus AC, AC is 7. So in total AB equals to 2x minus 7 units in its length. The next step, we completed this semicircle to a circle. Then we extended line segment PC by straight line until it touches the circle. We define the touching point of the extended line segment PC with this circle. This point is point M. Likewise, we define the short line segment, this short line segment CM as A. The next step, we implemented rule 65. Now we're going. Click on rule 65. Rule 65 is to any circle, so this circle could be any circle. So, according to rule 65, if chord AB intersects with chord CD at point O, then the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can implement rule 65 in our drawing. In our drawing, chord AB intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. Okay, again, in our drawing, chord AB intersects with chord PM at point C. Therefore, according to rule 65, the following equation is true. AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. AC times CB equals to PC times CM. AC is 7, CB is 2x minus 7, and it equals to CP, that is 21, times CM, that is A. So you should found out that 7 times 2x minus 7 equals to 21A. Here we divided this equation by 7, so here 7 will get cancelled, and the left only with 2x minus 7 equals to 21A over 7 is 3A. So in total, we found out that 2x minus 7 equals to 3A. Here we added 7 to this equation, and we found out that 2x equals to 3A plus 7. So, in the next step, we joined point Q and M together by straight line. By joining points Q and M, we created the green arterial MPQ. We have, this is peripherical MPQ. This is equals to 90 degrees in size, and it's subset on chord QM. Again, peripherical MPQ equals to 90 degrees in size according to what is given in the question, and it's subset on chord QM. So here we can implement rule 5. Okay, check on rule 5. According to rule 5, any peripherical that is equal to 90 degrees in size must subset on the diameter of the circle. In the drawing, we have a circle. This is peripherical MAN. This is equal to 90 degrees in size. And therefore, according to this rule 5, peripherical MAN must subset on the diameter of the circle. And indeed, peripherical MAN subset on chord MN, that is the diameter of the circle. So according to rule 5, any peripherical that is equal to 90 degrees in size must subset on the diameter of the circle. So we can definitely implement rule 5 in our drawing. Why? Because of the fact that in our drawing, this is peripherical MPQ, that is equal to 90 degrees in size, and therefore according to rule 5, it must subset on the diameter of the circle. Peripherical MPQ subset on chord QM, therefore according to rule 5, chord QM must be the diameter of this circle. So if QM is the diameter, it means that it's equal to 2x. QM equals to 2x. So in the next step, we implemented the Pythagoras theorem of this green arterial MPQ. According to the Pythagoras theorem, in any arterial, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this green arterial MPQ, according to the Pythagoras theorem, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. Repeat again, this green arterial PMQ, according to the Pythagoras theorem, QM squared equals to PQ squared plus PM squared. QM equals to 2x, therefore QM squared equals to 2x squared, and it's equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, plus PM squared. PM in total equals to PC, that is 21, plus CM, that is 8. So in total, PM equals to 21 plus 8. Therefore, PM squared must be equal to 21 plus 8 squared. So in total, we found that the 2x squared equals to PQ squared plus PM squared. So QM is 2x, therefore QM squared is 2x squared. PQ is 16, therefore PQ squared is 16 squared, that is 256. Plus PM squared. PM squared is 21 plus 8 squared. So in total, if you found out that 2x squared equals to 256 plus 21 plus 8 squared. We already found out that 2x equals to 3a plus 7. Therefore, we can substitute 2x here by 3a plus 7. 2x equals to 3a plus 7, it means that 2x squared equals to 3a plus 7 squared. 3a plus 7 squared. And it equals to 256 plus 21 plus 8 squared. Here we open the brackets on both sides of this equation, and we found out that 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a times 7, that is 49a. On the other side of the equation, we have 256 plus 21 plus 8 squared. 21 plus 8 squared equals to 21 squared, plus 8 squared, plus 2 times 21 times 8, that is 42a. So here we have 42a on both sides of this equation, so 42a we get cancelled. After we cancel 42a, in this side of the equation we left only with 9a squared plus 49, while on the other side of the equation we left with 256 plus 441 equals to 697 plus a squared. So in total, we found out that 9a squared plus 49 equals to 697 plus a squared. Here we subtracted a squared from this equation, we found out that 9a squared minus a squared equals to 8a squared plus 49 equals to 697. So here we subtracted 49 from this equation, we found out that 8a squared equals to 697 minus 49 is 648. So in total, we found out that 8a squared equals to 648. Here we divided this equation by 8. 8a squared over 8 is a squared, and it is equals to 648 over 8 is 81. So in total, we found out that a squared equals to 81. Here we took out of this equation, and we found out that a equals to the square root of 81, that is 9. So 9 cm is equal to a is equal to 9 units, and it's 9. We only found out that 2x equals to 3a plus 7. So 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 34. So in total, we found out that 2x equals to 34. Here we divide this equation by 2, and we found out that x equals to 34 over 2, that is 17. This is to say the radius of this semicircle, x equals to 17 units in its length. Our test was to find out the area of this semicircle. Actually, we know that the area of any semicircle equals to pi times the radius of the circle squared over 2. Therefore, the area of our semicircle must be equal to pi times the radius of our circle squared over 2. The radius of our circle is x, therefore the radius squared is x squared over 2. So in total, the area of our semicircle must be equal to pi x squared over 2. X equals to 17, so x squared is 17 squared. So in total, the area of our semicircle must be equal to pi over 2 times 17 squared. Pi over 2 times 17 squared equals to either 289 pi over 2 square units inside. So in terms of numbers, the area of this semicircle equals to 453.96 square units inside. Repeat again, the area of this semicircle, that is the area that we're looking for in this question, equals to either 289 pi over 2 square units inside. So in terms of numbers, the area of this semicircle equals to 453.96 square units in its size. Okay, thank you very much.